Hello everybody, welcome back. Today we're going to be working on adding manipulator change functions and editing logic, hopefully. Hopefully I have time to get to both of those things. But yeah. So, yeah. Alright, so if you're not familiar, manipulator logic is simply these manipulators that allow you to control parameters inside the graphics window. So like here, there's this one that's tied to the depth parameter. You can also click it to flip the direction, right? And so those are useful for visibility and whatnot, and for usability. And then editing logic is behavior that can run as you're editing features. It can manipulate parameters and make changes automatically. And so a pretty omnipresent example of that is extrude. When you extrude a new face, if it's adjacent, right, what happens is it actually will change the, if it's adjacent to one part and one part only, that's visible, it will change the behavior to add. It will, and it will automatically fill that merge scope in for you. And it will also set the direction intelligently based on what you've selected. So yeah, so we're going to be adding that to our bearing hat feature today. So hopefully we'll be able to set the direction automatically and add a manipulator for that, so users can change it if they need to. And also hopefully add an angle manipulator for the rotation, so they can drag it around, kind of similar to how the revolve feature works. So you can select your axis, and then there's an angle manipulator for your direction. Actually, it's probably closer in nature if I'm to something like rotate. And so let me just see the behavior real quick. Okay, yeah, so something like that probably. And this looks like it's using the center of mass of the extrude. And then they're using the edge, of course, the center of the edge, it looks like. So something like that. Yeah, so without further ado, let's go look at the source code for that and see how they're doing it, because I don't feel like figuring out all the logic myself. Okay, that's the wrong search. Right. And it's funny, it looks like the documentation actually tells you to look at transform copy for examples of some of the manipulator functions, so this is actually the Onshape recommended approach. So yeah. Alright, so manipulator change function, right? So we can go take a look at that. Yeah, and we also want to look at the logic for how they're actually adding them, right? So here we see, here's all the logic, right? So they have the axis, reduce angle, that's a new function for me. Let's take a look at that. Okay. Negative 2 pi to 2 pi. Okay, interesting. And that's similar to adjust angle as well. But that is actually a useful function to know. Although I do see it's not exported, actually. So if I want it, I'm going to have to copy and paste it myself, because it's not publicly available, which is a little bit sad. But you got to do what you got to do. Yeah, so I'll probably copy paste that. And maybe I won't use it, but we'll see. Okay, let's see what else we got here. So manipulator change, we'll go back. Okay, so here's the actual call. Wait, oops, sorry. Yeah, so rotation. Okay, so if you don't have an origin, they're using this find center. So target, yeah, and then they find the center of it. I assume that's using the bounding box that you're talking about, and they also have the axis. And then they reduce the angle. They apply the opposite direction here, and then they add the manipulator. Sure, pretty reasonable. And then they compute the transform as well. So I will steal this logic, probably. And then generally for manipulators, you want to get past your basic validation, right? But it is helpful to do them sooner rather than later in the future. So that way, for example, if the direction is facing the wrong way, everything is still correct. So I'll probably do it down, let's see here. I'm not 100% sure yet. I'll probably do it after I finish computing my transforms, but before I start sketching. So that would be right here, right? So here's where I apply the angle transform. So I'll look at adding the manipulator here. And then here, so we already are getting our angle, right? So we get that for free. I do wonder if you do want to reduce the angle so that it is in that range, because that did seem helpful. So I'll have to think about that. And then basically, yeah, so the way manipulator functions work, right, is you first create your manipulator, right? So this syntax is a little confusing if you're not familiar. So the basic is you know, my manip equals angular manipulator, right? And so this is just an object, right, you know, representing your manipulator. So you'll have whatever code. And then the way you actually use that manipulator is you have to call add manipulators, right? And this function is confusing as well. But basically what it expects is a mapping of keys to manipulators, right? And so if you look down here, right, you can see that's what they have. They have a mapping of keys, in this case rotate, to their manipulator, angular manipulator, right? So they've just inlined this call, right? So instead of creating a variable like this and doing it like this, they're just doing that in line, right? And then the key, right, is actually a variable. So instead of doing like, you know, my var key, they're actually using a variable. And so you can do something like this, right? Although this doesn't work by default because Onshape doesn't know if this is the string myvar key, right, or the value of the variable myvar key, right? So it's ambiguous. And so in order to have you disambiguate, right, so obviously if you're doing a string literal, you just add the quotes, right? That's usually the default behavior, and that's usually what you should be doing realistically. But there are situations where you're not allowed to have variables in the context, and you don't have to actually put that, but that's very niche. Otherwise, if you are using a variable, you have to explicitly say so, and the syntax for that is just add parentheses, right? So that's what's happening here, right? They have a variable named rotate that corresponds to the actual key they're using, and then they're mapping inline inside the add manipulators call. So this is a very common pattern. If you look at Onshape at all, you'll see it all over the place. But yeah, so that's what's going on there syntactically, right? And so I'll comment this out. Okay, and then we need an axis origin. Let's see here. So that is probably going to be our center plane, right? So we'll do circle plane dot origin, right? We need a direction. That will be our z-axis dot, or our normal. All right, rotation origin. So I believe, let's see here, what's going on. Yeah, so origin is the center of the part that they're transforming. We don't have that. So let's go look at, yeah, so if you look at the documentation, right, the rotation origin is the point at the tip of the revolve manipulator, right, so that should be out some amount. And I'm not actually sure how much we want out. So I'm going to go look at rotation or revolve and see if what they're doing over there. Right, so add manipulators. Right, so again, the same pattern, add manipulators. They have a key with a variable angle manipulator, and then they're specifying all the same patterns, right? And then here we see revolve point is a rotation origin, and they're grabbing the middle face. Okay, that's not very helpful. Let's see here. I'm trying to think of a case in the standard library where there's a revolve manipulator with like an arbitrary distance, right? One thing I'm thinking of is frame, right? So frame has this frame manipulator. If I think this is scaled based on the size of the frame you have specified. But this is another angle manipulator, right? And it has an arbitrary starting point. let's see here. Yeah, so that's one option. Let's go look at the source code for frame, I guess. Yeah, otherwise, do we have something I could position off of? Let me see here. I mean, if you're choosing, well, it's just an angle. I guess you could use like the overall bearing hat size and scale off of that. So maybe that's what we'll do. So let's see here. Yeah, so manipulator plane not normal, and this is here, and then they're getting get plane at line start. Let's see here. Angle manipulator. So their rotation origin is profile data dot half extents. Okay, that's fancy. Let's go take a look at that. Dum half extents. 0.5 times bounding box max corner minus bounding box dot min corner looks like the calculation. Oh, that's an old version, but I would assume that's the same. Let's take a look. And they're multiplying that by 2, so it's just the diagonal, basically, of the bounding box around the frame. Let's see if there's a new version. Half extents, offset data. I mean, weird. Get points manipulator data. Wait, so this is a new version. Where's this coming from? Offset data? Get alignment point offset data? Oh, this is a different function. Okay. Yeah, so B-box, they get a B-box around it, it's tight, and then they do half extents. Yeah, and this is, I believe, this is the logic for, so these are the points of the points manipulator you select, so these are just, all the locations of it, that's how they calculate it. That's why it's like a, 1, 2, 3, 4, 5 grid, like a numpad. And then this is, what they use for the angle. Sketch plane center, so this offset. Okay, yeah. And then we see when they're applying it, they're multiplying by 2, so yeah. So we'll probably do something similar. Okay. And technically these are hard-coded values, but I'm a little lazy. So, do I want to do that? I guess so, right? Because we're computing the bounding box down here anyway, right? So I'll just scoot this up. Oh, that's around that's our scope, so that's different. Is it worth it? I could just not. Okay, well, if they're just doing that, then I guess we'll just use the width, right? So we'll say our width is 2 times inches. I know it's just like the standard, and then eventually there will be selections for different options, and then that width will change, but we'll just go off of it for now. So like this is width divided by 2. And because width has units, right, because I added the unit here, right, it's an error to add it again, right, because this already has units, so if I multiply it by inches again, then this will become 0 inches, which is correct, but this will become, like 2 inches times inch, which would be 2 inches squared, which is an area, and that doesn't make sense. Right, because this is not an area, it's a length, and so we have to do it like this as well. Yeah, okay, cool. And then they're doing, so they're doing the bounding box times, they're just using the bounding box, so we'll just do that as well. So I'll just do circle plane dot x plus width divided by 2. Times, right. And this is the origin, so I'll have to add it to the origin. So this is the origin, that's our starting point, and then we add in the x direction width divided by 2, right? And I guess they're doing diagonal, this is half, and then they multiply by 2, so we'll just do width. And then angle, that's our angle. Sources sources. I think this is getting into the internal stuff now. But I will look at it just for posterity, because sometimes that stuff is helpful. Transform lookup. Okay, we'll go. Let's see here. So sources is here is our target. So that's the thing they're rotating. We don't really have that, so I'm not going to worry about it, because the thing we're rotating is being generated by this feature. But we do have a primary parameter ID, which is angle. It's the same thing. Cool. All right, and then I'm going to update this function. All right, so I'm going to do the same thing that they have, where they have this variable named rotate. Let's see here. Where is that declared? Yeah, so here it is, right? There's their manipulator. So I'll just slap that down here, right? I'll give it an, I'll add manipulator because I like being explicit, right? Cool. So we'll save that. And so if we've done everything right, so I haven't hooked up the actual change function yet. I've just added the manipulator, but we should see it now. And we do, right? And so I can drag it, which I shouldn't be able to do. That's kind of weird, actually. But if I change this, we see it updates. And then I guess it keeps its like own internal state or something. Let's see here. Yeah, because that shouldn't be changing without me updating the angle. So that's a little surprising. But I guess it keeps its own internal state or something. But we can see like whenever we change the angle, it changes, right? And that's good, because generally like the oh, that's actually not 100% right, is it? No, it's not, because this axis should be static, right? Like if I change this axis should always point towards that, and it's not, so that's not good. So axis origin, axis direction. That's the axis. Let's see what we're doing wrong here. So if we look at transform copy again, let's see here. So, oh, they're projecting the axis. Oh, they're projecting the origin onto the axis. No, that's fine, yeah. Axis dot direction, origin, angle. Let's see here. Our angle here is the reduced angle, and then we flip it potentially. Okay. Axis origin. Yes, that's the center of the axis. That's fine. And that's the normal, yes. And the rotation origin. Let's check the documentation. Point at the tip, and then the angle is measured from that. Oh, they did document it now, finally. That's nice. Although sources is still Onshape internal use. That's funny. But yeah. Okay. Okay. I don't know if my behavior is wrong or if there's some internal state or something going on that's causing weird behavior. Oh, there is, I think, because, yeah, so this is after we've applied the transform, which is wrong. So I think we actually want to apply the transform down here, right? Which is a little confusing. But basically the order matters here, right? Because you look here, right, they're computing the transform, right, but they haven't actually applied it yet, right? Because like this stack just, you know, computes the overall transform to apply to the body, and then they don't actually do the transform until they get down here. And here's the actual OP pattern they use, right, to do it, or the call sub feature and transform, I guess. You know, one of those two, depending on if it's a copy or if they're just transforming. And so I think we need to do something similar. We don't want to move our plane until after we've applied it. So let's see here. Okay, so, yep, okay, this is correct now. Yep. So we see basically what happens is if you don't touch the manipulator at all, right, before you've hooked up your manipulator change function, your manipulator should always reflect the state of the feature, right? So if I flip this, it should flip, right? If I increase the angle, it should increase, right? So the manipulator should always follow the feature because the feature values, these values in the parameters, are the source of truth for your manipulator, right? And so sometimes it can get a little confusing exactly what's happening, right? But that's basically what you want. And so like if this is 0, right, that should follow, which it does, right? And so we can see like, whatever I enter in here, this is always going to reflect that correctly, right? So we started at 15, now we're, 45. If I go like 90, right? And if I set like my angle reference, right, it shifts relative to that. If I want to point directly at my angle reference, like I can do that as well. So it's, it's all logically consistent. And that's very important. So once we've done that, then we know we've added our manipulator correctly, right? So now we can worry about hooking up our manipulator change function, right? And so here, right, yeah, so here's their function. I'm just going to copy paste the entire thing because I'm lazy. Let's see here. Okay, and then we don't need the documentation, that's fine. And then obviously we need to give it a name. So we'll do that. And this is a pretty common pattern, robot bearing hat manipulator change. I don't like these naming schemes one bit. Because typically, right? Yeah, typically the names of the parameters are these, right? So they've named it to output and input, which I think is a little goofy. But basically what's happening, right? So yeah, so typically the standard, right? Rotate manipulator equals is manipulator, right? And actually it's wrong. It's new manipulators, right? So this is how you check if a manipulator has been set or not, because if you have multiple manipulators defined, the manipulator change function isn't always called with a given manipulator, because if another manipulator changes, it'll call this function regardless. So that's how you check whether yours is right. And then typically you can do const angle manipulator equals new manipulators, right? So this is so new manipulators is a map, just like the one you passed in to add manipulators, right? Mapping keys to manipulator objects, right? And so this syntax here, right? This is equivalent to new manipulators dot rotate manipulator, right? Which is this value here because that's the underlying string we've been using, right? But the key is because it's in a variable, we want to access via the variable, right? But of course we can't do this, right? Because if you do this, this looks like I created a map like this, right? Equals, rotate manipulator, my manipulator, right? Which is not what we have, right? We have, it's secretly, this, right? And so the way you get around that is you can use this bracket access, right? And the bracket access is equivalent to the dot access, except it takes a literal instead. So this is equivalent to new manipulators dot rotate manipulator, right? These are one and the same. But then the key is with brackets, because it takes a value, right? You can also put a variable in here. And when you do, right, then you get the variable value. So this will end up being this after, the resolver runs or the parser at runtime. And so then you end up with, this is your final result. So that's what the bracket syntax is doing, right? So it's just a different way of dot access that allows us to access using a variable as opposed to like directly. So hopefully that makes sense. Yeah, so we'll get our angle manipulator, and then our angle is going to be angle manipulator.angle, right? So this object has the exact same key value pairs as this function, right? This is really, all this function does actually, it's just a type constructor. So literally all it does is it verifies the keys and values are correct, right? It does some type checking, but then like it does a little bit of modification, but then the big thing is just cast it to a manipulator. So it's just setting the type basically. So, it's really, like this function is very short. But yeah, so basically the key value pairs are all the same, right? But then the thing is like Onshape will update the angle based off of what the user has, clicked and dragged it to, right? So the key is mapping that, the new angle back to the original, or back to your parameters in the function, right? And the way we do that is we use the absolute angle to get the angle, and then we determine if we need to flip it or not, right? Based off of whether or not the angle is less than, greater than or less than 0, right? Yeah, and then we return the new definition, right? So all we're doing is we're checking if our manipulator exists. If it does, we get the new angle that was set by the user, and then we set our angle to the absolute value of that, and then we flip based off of whether it's positive or negative. Because if we're supposed to flip, then the angle will be negative, but we try to keep the angle positive, just for like usability. Instead, we apply like the opposite direction, and that's just like semantics, right? Because that way, like if the user clicks opposite direction, the angle we get will still be negative because there's no like opposite direction flag in the manipulator itself. But we'll keep the absolute value of that and we'll just flip it because we'll see like the sign has gone negative. So by doing this, it keeps it nice and consistent. And then because they're reducing the angle here, we'll do that as well. So the manipulator doesn't jump around or whatever. So we'll do this. Right, and let me make sure. Let's see here. I'm all turned around now. We'll go back, reduce angle. What? Yeah, okay, and they apply it before they multiply. So we'll just pay attention to that. Okay, ta-da! Cool. Cool. There's our width. Yeah. All right. So we'll give that a shot now. So we can see now if I drag this, right? Oh, oopsies. Important step I forgot. You do have to also specify then your, you have to specify when you're creating your feature. You just have to tell Onshape what your the name of your change function is, so it's hooked up. Change, right? And we'll have to do the same thing when we hook up the extrude function as well. So we'll give that a shot. Ta-da! Yeah, so we can see it changes, and then because we're using reduce angle, when it goes over, it flips automatically for us, which is cool. And then we can do it like that, right? And what happens if we enter like 200 degrees? Okay, yeah, so it gets reduced, so it like automatically flips to 120, which is neat. And hopefully no one's doing that, but that way if someone enters like 370, you get like 10 degrees, and it is kind of logically consistent. And then when you like actually change it, because it we are using reduce angle on it, it'll snap back to whatever it's to that 0 to 180 range, which is good. Yeah, so ta-da! That all works. It's consistent with our angle reference, and we can rotate it. Yeah, so pretty neat. Okay, cool. So there's that. Let's see here. So what else do we have? So I think the other thing I wanted to add was a flip manipulator for the direction, right? So handling this. Although actually now that I think about it, if our editing logic is working, then it should just always be facing the right direction, so that might be moot. So maybe I'm not going to worry about that right now, and I can come back and add it if I decide it's important. But I think the angle manipulator is the big thing, because people shouldn't need to set the direction anyway, most of the time regardless, so it should just be fine. Yeah, so let's do that. So the logic for that is we were looking at what's a good standard library feature? I guess we really did, like, the logic shouldn't be too bad. We were looking at that evaluate mate connector right? So remember, if you watch episode 1, I guess, oh, here they use it as well. That's funny. Yeah, so we saw when we were looking back here a while ago, right, that the manipulator was using, or make connector uses this function, evaluate make connector coordinate system, to figure out which way the z-axis should be facing, right? And so we could do it in line and just kind of hope that that works. And I don't think that's unreasonable. It's honestly very tempting to do. My only thing is, I think users are kind of used to having like flip primary next to rerun it secondary. So I think it might be a bit weird to have flip primary there. And maybe there are edge cases where they do want it facing the other way, or that gets it wrong or something. And so having that is helpful. I don't know, it's just kind of what people expect. So I think it's better to provide them that, even if it's maybe not 100% right all the time, or even if it's a little extra. Yeah. Definition, new definition. Oh, that's cool. Okay, so so with that in mind, let's go steal some. Yeah. Okay, so if we look at this, right, it takes a definition. How documented is it? Picks and inferences for defining a make connector as a desired coordinate system. Okay, that is not very helpful, actually. Because I'm realizing this gives you all the flips and stuff, but it doesn't actually, oh yeah, we can look at external thread. That's right. External thread is probably the best example of this, because it's just literally what we're doing as well. You take a cylinder edge, and so they don't actually even, not a convex surface, okay. Yeah, so they don't have a flip direction, actually. And so if that's the case, I'll probably still have it, but that's good to keep in mind. So let's see here. So this is cylinder, or external thread. So let's see what they're doing. Right. Okay, entities, depth type, chamfer, yep. Okay, existing thread. Yep, chamfer. Let's see, I wonder if they're using now surface definition. Okay. Let's see what's happening. So, okay, check existing, check and split all, check non-matching size, add chamfers, add undercut, queue adjacent cylinders. Huh. Per edge function highlight. Get split data. Okay, so using queue adjacent to get the adjacent faces, the faces adjacent to the edge, right? And then they're iterating over the faces, and they're checking if it's a cylinder, right? Although I do notice current surface is only used in the case of if it's planar, because these don't actually depend on it. So it is kind of goofy, actually, that they're using evaluate surface definition, because this call could just be moved into here, and then it wouldn't run if it's a cylinder or a cone when they're not using the behavior. But that's neither here nor there. Nobody's perfect, I guess. And maybe I could be missing something. Although, no, I think that's right. Yeah, because this isn't getting used anywhere except here, so you could just put this in here. Although, I don't know, maybe they're relying on this throwing an error if it's just not a valid face or something. But it's not a try-catch loop either, so it would just crash the feature, potentially, unless this is in a try loop. Anyway, regardless. Sorry, it's been a long day. Okay. My voice is not 100% there. Alright, so they're getting this, they're getting a shaft query, right, thread boundary, end cap surface. Oh, I see. Okay, so they're relying on, wait, face? Okay, current surface. Oh, I see. Okay. I see. Okay, so they actually are iterating over, and then, okay, I understand what's happening now. Yeah, so they're getting the current surface, and then basically depending on whether it's a cylinder or not, they're getting the shaft query and the end cap. And then, this way they're able to guarantee they have a shaft query and an end cap, right? And then here, so this is where the magic's happening, cylinder direction, right? And then here, so compute cylinder, okay, and this just is the axis. Whole tag feature, really, okay. Does that work? Faces? A surface? Wait, so the shaft query here is the cylinder face, and then the edge, oh, okay, edge direction info. Okay, so evaluate curve definition, curve. Oh, does this just work? Cylinder bounding box, no. Okay, I see. To cut needs to be inverted. Okay, so this is a function that they have. So this is the benefit of using Onshape standard library stuff, right? So here they have some shenanigans. These are some top tier shenanigans to figure out exactly whether the court system needs to get flipped or not. And so I am definitely going to borrow this. Yeah, so I would need this function as well. Does this use anything? No. Okay, perfect. So I just need this and this. Wahaha. Right. Yeah, because neither of these are exported, so we are going to have to Control-C, Control-V. Right. And then we don't need this. They're not using that. Okay. Ta-da! Yeah, so it looks like this takes a shaft and then an end edge. And here the shaft is the cylinder, which we should have, right? Or we're going to have to query for. So, which we can do, right? So const cylinder equals q const adjacent. So definition dot bearing edge. Dot edge, entity type dot face, right, and then q geometry type dot cylinder, right? So all cylinders, right? And then we do if query count adjacent cylinders does not equal 1, right? We're going to have a region error. Must be adjacent to a single hole. We'll just call it a hole. And yeah, better to use language that users are more likely to understand. Or like plain language. Because not everyone's going to know what a cylindrical face or a cylinder is. But if you say it needs to be adjacent to a hole, like, you know, because if they're doing something silly, they'll probably figure it out. Like if it's next to you know, like a counter bore or something, where it's, you know, angled. and you say it needs to be adjacent to a hole, like hopefully people will put 2 and 2 together. Okay, so yep, so that's there. Okay, what else do we need for our fancy function? So we scroll down again. So we need a shaft face. I'm gonna rename this a shaft face so it's clearer. Actually, I'm gonna name it whole face. Right, and they call it cylinder entities down here even. So, okay. So, and then we have our cylinder face, and then we need a chord end edge. Okay, and that's just our very edge. So we should have everything we need, actually, which is fun. Right, so that wasn't very hard at all. Const direction, or... temp equals... Oh, shoot, what was that function called again? Get edge direction info. Oops. Direction info. Okay, cool. And then we have our whole face and our definition dot bearing edge. Ta-da! Okay. Right, and then I believe this just has a chord system, which is cool. And then there's a need flip here. We don't need a length either. I don't think. So I'm not going to worry about that. Oh, actually, are they using that for... Ooh, if that's the length of the whole... Well, I don't know. If someone's doing like a weird droopy thing or something, I don't have a problem with that. So I don't really need the length. And here, if it needs a flip, I'm just going to do it immediately. Because I don't really... Wait, hold on. Let's see. Needs flip. Yeah, because they're just multiplying by z-axis anyway, right? So if that's going to be the case, we're just going to do it. Equal -1. Right, I could also use my ternary operator again, but whatever. So we'll just say this returns the chord system, right? And we'll just return, chord sys. Okay. This is a var. And this is a const, right? Okay, and we'll comment that out. Alright, and this returns a box 3D. Come on, Onshape, document your functions. And we'll just streamline this to like that. And that's just me, like, being extra for no reason. But I like doing stuff like that, so I don't know, it makes me happy. Okay. Yeah, so there we go. Okay, so there's our edge info. So this is actually just a chord system now. So our trickle plane equals that, and then we just make it a plane. Right, and then we don't need our circle.chord system anymore. Oh, this is a var because we're about to do a bunch of transforms on it. Okay. Yeah, so we don't even need this logic anymore, technically. Although I think it's still, well, yeah, I'm not gonna worry about it. If it's not adjacent to a hole, then yeah. Okay, yeah, because this already has the evaluate curve definition implicitly in there as well for us. So if that fails, then it fails, and yeah. All right, let's see what we got. Do I need to... Oh, because they're cutting threads down? Well, I assume they've defined it differently. Because their z-axis probably points along. Because I remember I put a negative sign in our extrude here for no real reason. So I'll probably get rid of that and just use Onshape's definition. Okay, cool. So that works. You can still flip the primary axis, which I guess if... I mean, based on... I mean, if it's good enough for Onshape, it's good enough for me, right? If they're saying they don't need that, then I think that's fine. The other thing I'm noticing is they did have a warning for inner holes, but we can steal as well. So that's just a bit of error handling, right? Although that's extra. People can figure it out, but I don't know. It makes me happy. That checks if there's already one there. Wait, is that massively over-engineered? Get attributes, entities... What? Oh, I guess I have to check the value. No, but you can just check... What? Wait, this is like so over-engineered. Okay, this is just me doing code review of Onshape now, I guess. I'm pretty sure, so I might not be 100% correct, so I'm going to be 100% validated. But there is this QHas attribute with value matching function, which queries for entities with a name and value, and it even has a query to filter. So this entire function could, in theory, be, you know, if is query empty context Q has attribute with value, name. Oh, are they using old? Is this the legacy version without a name? Wait, why are they using legacy attributes? This feature came out like a year ago. What? Oh, whole attributes. Oh, I guess they're okay. Yeah, backwards compatibility. Because whole attributes use legacy attributes because those came out in like, you know, the beginning of time. And they probably never migrated because why would you? So that's why they can't use the fancy new functions. Okay, that makes sense. Anyway, all right, sorry, that was a massive... that was a massive sidetrack. That was completely unrelated to anything we're doing. Yeah, basically there's attributes and there's fun things you can do with them. I don't know, maybe eventually I'll make a video where or maybe eventually I'll make a feature that uses attributes. Or, you know, write a new one. I have some existing ones that do, but, you know. And I'll talk about those in more detail. Okay, so that sets the direction. And so in theory, you don't need the flip manipulator anymore. Although, I am very hesitant to get rid of it. Because I do like having the flip there. Also, I did say I was going to do editing logic, and now we just haven't. So that's kind of boring. But I do like, you know, that setup is very familiar to people. So I worry if you get rid of it. But I guess, like, I don't know. I guess in theory, like, whatever direction you set, it will set it automatically. And if somehow I've messed up the function or, you know, there's some edge case where it doesn't work, then the user can just flip it. So I guess I'm going to leave this for now because I think it's better to be familiar than to worry too much about, like, you know, eliminating every parameter I could. But this is like a fun edge case where, like, I probably could just delete that with very little consequence. And maybe I will eventually. But I think for now it's just better to be consistent with transform. So it's a little more usable, or just a little more familiar, I guess. But it is kind of interesting. So, okay. Yeah, so I wasn't expecting this to be 100% reliable, but I mean, if Onshape says it's 100% reliable, you know, then okay, I guess it is. So I'm not going to argue with that. Let's name this get edge direction. Okay, we'll leave that for now. So eventually I will go through and update all these functions and, functionalize this. Right, I will document that I stole these just for myself, right? The SCD is all open source, so you can do whatever you want. Otherwise, I wouldn't post it. But it's good just to document that this is someone else's code. This is not necessarily my code, so I know if it's a reference. And that way, if they ever change or anything, I know where to find it. This is borrowed from transform copy. And I'll inline this documentation. Okay, cool. All right, ta-da. All right, so that works. Yeah, so we don't even necessarily need an editing logic function then, which I'm perfectly fine with. But basically, editing logic, you'd just be checking whenever bearing edge is populated, you try to set the value of flip primary based off of that. So like, this was returning needs flip, so you just set like definition.needs, definition.flip flip primary axis equals definition or equals needs flip after computing all of these things again. Or well, it would just be off the edge in the whole face, I guess. So it saves us from having to duplicate that logic a little bit, just doing it in line, which is nice. So yeah, so we're quite happy with that. Okay, what else do we have? So fit, that works. Okay, I guess while we're here, so there is one other version I want to handle. So there's actually a couple different styles, but the big one here is there's technically 4 versions actually. So there's a 1-inch wide and a 2-inch wide version, I believe. Yeah, so this width is either 1 inch, right? That's a 2-inch wide version, or 0.75, or I guess even 0.65, depending on your bearing size as well. So we're going to want to capture that in the UI and support all of those options because we may as well. Yeah, so we'll go ahead and define some enums for that. Let's see here, and I have to decide. Let's see, so they have all 4 in line, right? But you could also very easily have an enum for your bearing size. So you select, larger, or 1.125 inch bearing or 0.875 inch bearing, and then your center to center on top of that. Although that is a lot more UI. I guess I'll do the easy thing and just have it be the 4. So, okay, and then what naming do I want? Yeah, and these are generic. I mean, these are the ones like, multiple sponsors sell like different versions of this. So maybe this will be bearing mount and retention plates. This is just a retention plate. Let's see here. Maybe I'll just borrow WCP's naming scheme. So 1.125 inch bore, 2 inch center to center. Okay, I guess we'll do, okay. I guess because fitting it all in one line is kind of awkward, I will do the 2 bearings thing. hate that. Can I put a... There's no way. I shouldn't be able to, right? Yeah, no, I can't. I guess we'll call this large bearing and small bearing. No. 1125 bearing, I guess. It's a little cringe, but it'll have to do. Okay. Do I have an enum for this anywhere else? No. Yeah, just here. Okay, that's fine. Yeah, and then, so then I'll have to do export. Oh, I'm not happy. I don't love this. Maybe I should just do all 4 in line like this. Yeah, these are always the hard questions. Okay, maybe I'll do... Okay, let's do this. Bearing hat, hash name, 1.125 inch bore, 2-inch center to center. Oh boy, I have to give this a name. That's awful. Is that readable? Oh boy, that's terrible. It's such a mess. Oh. Okay, and there's a 0.875 inch version, so that's 2 and 1.25. Alright. This is a little cooked, to say the least, but... Okay, maybe something like this is not the worst thing I've ever done. I hate that there's... There should be an underscore here, I guess. Okay, let's try that, I guess. Right, the other thing I could do is I could make a manipulator change. So I could do a lookup table, right? And that's probably the most, correct thing to do, honestly. Although lookup tables are, let's see, so this is what a lookup table is. I'll show it. Oh, I guess, okay. Sure. So a lookup table, the classic example is the whole lookup table, right? So basically you have a set of cascading options, and what you choose here affects your other options, right? So you can kind of drill down the table. And then Onshape has a habit of doing the synchronizing UI bit, so you can modify on top of it. And they've gone through a couple iterations of this, actually. It used to be this would drive this, right? And there's like a default option called custom, right? If you didn't know what you wanted to do. And the way it worked is if you ever changed this down here, it would change the table automatically up to custom. And so recently what they've done is they've instead switched away from that. So now instead, if you override the table, then you just get this warning, or not even a warning really, it's just an info message saying, hey, FYI, like these parameters don't match what's specified in the table. If you ever do change the table, then it just sets the parameters again. So that's kind of an interesting thing that they've done. Yeah, so I do think a lookup table is the most correct thing here. I don't love them because they're kind of a pain to write, but I guess we can do them. And there's a handy example right here that we can copy and paste. So I guess we'll do that. Although it does make me a little sad on the inside, but I guess that's fine. Whole table. Bearing hat table. For bore. The default will be the first entry. Oh, actually, we do need the default here. 1.125. Inch, right? Is that what they do? Let's check. Let's check. Oh, I guess there's not really. They do like quarter. It's just kind of implied, actually. Yeah, I guess we'll do the same thing. One and an eighth, like that. No, we don't like that. We'll do 1.125. Do I put the units? Do they ever put units in here? How would they do? Will they put the leading 0 if they needed to do, like, you know? Oh, I guess they just do 7/8. That's fair. They put the units there. I guess that's just the standard, though, because, like, here they do 1.5 or 1 millimeter. So I could just do that and put the IN. I'll probably just do that. I'll do my own thing. Okay. And I do want, for posterity, I think it's better to do smallest to largest, so I will put this here. So I will have this the default. Yeah, but basically it's just a nested table of key value pairs, and they have their own goofy values here. And then because the bore and the value need to be different, let's just keep working our way down. So there's bore, and then we'll do width, right? Width large. Default will be 2-inch. 1.25-inch, and then we'll do 2-inch. Cool, right. And then for the values, right, so I need to know based off of the keys what they've gotten. So we'll do it like this. 1.25 times inch, and then the this has a width of 1.25 times inch, right? And this has a bore of 0.875 times inch. Oh, I actually got the bore wrong there. This is 2 times inch. Right. And so this is obviously very tedious. And I do actually have some code to do this automatically a little bit, or like automate the generation. But I don't feel like using that right now because I'm lazy. And I don't really want to dig it up because it's kind of old and I haven't touched it in a while. So I'm just going to type this out by hand for now. But I probably should at some point dig it out, especially if I decide to keep going with this and make it bigger. 2-inch, and then this is 1.5 inch. So this is 1.5, and this is like this, and this is like this. Okay, ta-da! So there's our bearing hat table, and then we'll use it. So we just do this, and that, I guess. Oh boy. Copy that, take that, take that, okay. Lookup table path, bearing hat table, do they do? Size, lookup table, so to size table. Yeah, that's about right. Okay. Right, and so this, right, should be a map, right? It'll be whatever value here I specified. So here it's a map of with the keys bore and width, right? Which is the same as the values. So yeah, that's a fun fact is you can, like, if you use a map or another data structure that has arbitrary values, then you can put whatever you want. So you can, like if you have nested tables, that's pretty helpful. It's a pretty helpful pattern to use. Yeah, so then in terms of hooking this up, I guess I'll just hook it up real fast because I'm lazy and it's getting late and I'm tired. Yeah, so then all we need to do, right, so we're setting our width variables down here, right? So we'll get a bearing hat, and then our width, right, will be bearing hat width, right? And actually I'm realizing now we don't actually need the bore. It doesn't matter at all because we're not modeling that. So oopsies. But we have it if we want it for whatever reason. Maybe in the future there's validation to check the bore size is somewhat close. But yeah. Okay. And so here's what that looks like. Actually, what I'll probably do is I'll probably move the whole fit into that as well, just for posterity. But yeah, because if you're doing holes, then that all works. That all dovetails quite nicely. And the question of where to put it, let's see, hole, they do selections, merge scope, selection, and then depth stuff. So we'll do selections, manipulations, and then I guess I'll just go down here as the most logical place for it. Right. Okay. Right. So now you can select your bore, and then you can change your width based off of that, and you get the error handling. So that's cool, right? And like this, right? Like, I mean, this is a lot better than like feature failed, no regenerating, right? Because then you're like, you don't even get the manipulator or anything, and you're just like confused about what's happening, right? Whereas like this, it's very clear oh, it's too small, my hole's too big, right? I need to update it. So that's very helpful. So yeah, yes. Yeah. And then yeah, and then I'll fold the whole fit in here as well. And so for that, I guess we'll, as it gets deeper, I'm too lazy to break out my library. I'll just code it by hand for now, I guess. Const fit equals, can you do static functions? You can't really. No, okay. That's unfortunate. So yeah, so the problem is you can kind of see the exponential nature of this, right? Because if I add the 2 fits, then there'll be 8 options, or there'll be 8 leafs I'll have to define. So that's a lot of code to write. So I guess I will dig out my lookup table code. And I wrote this a long time ago, so bear with me as I struggle through the old API. So this will be our bearing hat table gen.fs, right? Let's just see what I have here. Okay. Okay. I don't actually need to export it even. Okay. So let's just see what API. So bear with me, I'm going completely off memory. Well, I mean, I have this example here, but table equals lookup node. Let's see here. So if I remember correctly, this is a mapping of lookup nodes, and then they just kind of nest together. So bor, let's see here. Okay, let me go back. And I think at one point I did want to port this to Python, and I probably will at some point. But it is nice having it in FeatureScript, I suppose. Okay, so let's just copy paste this over so I know what I'm working with. Okay. Yeah, so lookup payload. Wait, how does this work? Okay, so lookup node entries. There's a default entry I can specify, which I will do, 1.25 inch. Right, so this just corresponds to a lot of it. And I can add a lookup payload. And then a value. And this is just a key value pair. So here I can say everything in this. I mean, I don't actually need it. I don't need to add anything to this tree, so I won't. Okay, and this is an array. So I think I can put more lookup nodes here if I'm remembering correctly. And then I think, I'm forgetting how this works, but I don't know. Maybe it works like this. Is this right? Lookup payload. Yeah, okay. Oh, and then you can do, no. Okay, I think I'm remembering now. Okay, so I don't actually need entries here because these don't actually add a payload, right? And then I can do my, okay, wait. Okay, bor node equals lookup node. Okay. This is not a very good tutorial. I'm sorry. I'm just trying to remember how this works exactly. Okay, yeah, so then here I define my lookup nodes? No, my payloads. Okay, yep. Right, and so here, wait, what? Okay, let me look at the source code. A lookup table can generate for an array of lookup nodes using recursion. You said it's appended to the value when a leaf is reached. Okay. Okay. Right, and then you have to set next node. Okay. And then you print the table. And then I have a print lookup. Okay. So yeah, so this creates a table. So I just need this. Lookup payload. And I need a key, and this will be our 1.125 inch. Okay, so this is like this, and I don't have a value because these don't actually need to add anything. 875 inch, okay. Right. Oh, okay. I guess I never added default constructor. So that's what I get for making assumptions. Okay, set next node or node, and then I can do this. And then here I can do my, oh, okay. You need the value. Okay, let me satisfy that for now. Okay, so if I remember correctly, there is another overload. Where is that? Lookup node.entries. Yeah, there is. There's supposed to be overloads. Why aren't they showing? Okay, there it is. Yep. So there, yeah. Okay, yep. Okay, so I can add other nodes here. So I'll define my I guess I'll just do it inline. Name, this will be width, right. Don't need a default value here. Actually, I do need a default value. I need 2 inch, right. 1.25 inch, right. And so here's the magic, right. And then this will be 2 inch, right. And so here, this is the magic part, right? This is the part that makes this better than just doing it by hand, right? So there's this API here, and this is still very clunky. Like, there are definitely a lot of ways I could improve this if I spent any time on it. What happened? Yes, right. Okay, format, please. Oh boy. This syntax is something for sure. Let's do this, I guess. Does that help? I don't think that helps, but okay. Whatever. Yeah, and then this is 1.5 inches, and this is 1.5 inches, right? So there's that, and now I can do my fit node, right? So I can do whole fit. Fit is gonna be, I don't care. And then I'll have close, right? Inch, right? And then we can do our free fit. 0.21 times inch. Wait, let me go check that. Wait, where am I going? I don't need to go there. This is close, this is free. And let's just check with the whole table. So it'll be clearance, and then it'll be fastener fit, close and free. Okay, that's actually quite wordy. Yeah, no caps or anything. Nope. Okay, cool. Ta-da. All right. So the neat thing about this, right, is when I do this, I can do set next node, and I can do bore node, right, and then I can do fit node, right. And so theoretically, then this is my lookup table. So when I go and I add my bearing hat table gen feature, right. So what this does is it puts it in the console. When I'm not searching and I'm actually in the console. Yeah, so it puts the code in the console, basically. Yeah, and I don't need this in here. I should really add a disable option, but I'm too lazy, so I'll just do that. Okay, so I've copied it, right? So now, right, okay, so explain what's happening, right? So the idea is, oh boy, it's not printing correctly. Oh yeah, that's right. I have to string literal it. Again, not very, not the best thing in the world. Right, and the nice thing, and the other nice thing is these are functions, so you could write like functions to generate lookup nodes and stuff and like compose. So you don't actually have to hard code all of this, right? Because unlike static time stuff, this will actually run. Default undefined, really? Okay, just add that. Do a little programming on the fly. Right, all I did was add a check for if default is undefined, then don't print it. So that gets it out of there. But yeah, so then why isn't that working? Come on. Lookup payload, key string. Wait, where is my width? Let's see here. So I have my name. Oh, I don't have my width in here. That's why. Whoop. Wait, no. Lookup node. Lookup node. Next is lookup node. Come on. I thought this was how this worked. Lookup payload, lookup node. Yeah, that should all be set. Let's just check for node, I guess. Okay, there's a problem with set next node, clearly. I might have to do this. I don't think set next node recurses properly. So I have to do this and then fit node. So this is very excellent syntax. Oh boy. There. No? There. Yes. Okay, I had it right the first time. Nope, did not. Extra parenthesis? Oh no, it's cooked. Alright, abort. Oh, not that far. Okay, like that. Like that. Okay, set next node, lookup node. And then we need lookup node, comma, fit node. Okay, like that. All right. There we go. Okay, so there's the composition we were looking for. Yeah, so like I said, very rough around the edges. I don't expect anyone to actually use this, right? Or well, I definitely need to just polish it up at some point. Maybe if someone asked me really nicely on the forums or something. No, I don't know. Does it need to be exported? I don't think it does. But yeah, okay. So basically what happened, right? So what set next node does is it iterates over all the nodes and then it sets the next one, right? So it allowed me to reuse that fit node. And then basically what's happening is the composition, right? So you can see when I add that fit, anytime the close key exists, you get hole diameter 0.196 in your final result, and free you get 0.201, right? And vice versa, right? And so basically it generated like all 8 permutations for me, kind of automatically, right? And then of course it also does all the syntax and parentheses and whatnot. You just hit it with the formatter, because FeatureScript handles that. So that actually does make it pretty easy to generate really goofy large tables. And of course you could also write your own version in Python or what have you, and just print the syntax to console and do something similar. Or even like be like Onshape, and they have like big tables in here, and what they do is they have an external tool. I'm not sure what, but so that's how they like generate like a lot of these enums. It says like automatic generate file. So they're like they just have these defined externally, and then they just export them all, and it generates those files for them. So they don't so they don't even like type lookup tables by hand, which is probably fair. But yeah, so you have our lookup table, right? It has all our options, and then there's always close and free as an option. So we don't need our whole fit enum anymore, which is nice. Always feels good getting rid of code. All right, and so now this, right, is simply going to be our bearing hat dot hole diameter divided by 2, right? I'll put that up there, right? So yeah, and so that should do it then, right? So we can do our 2 inches, and this is 0.196, right? And if we change this to free, right, now we have our 0.201, right? And if I really wanted to be fancy and totally nerd out, I could steal the hole diameter feature as well and set that. And now that I've said it out loud, I don't know if I can stop myself from doing it. Why am I like this? Should I actually do it? I don't think so. I think I'm too lazy too, if we're being completely honest. Where is this defined? Here it is. Yeah, so the fun fact about the hole diameter feature is this parameter name, hole diameter, is actually sacred. Right. And so basically what happens... Oh yeah, hole diameter bounce doesn't exist. Ugh. Don't I have an STD hole feature that I made? Yeah, because this isn't exported, so you just have to like do it yourself, which is so sad. Okay, but yeah, so you can do that, and so the hole diameter feature name is actually sacred, so anytime you have it, it will automatically fill in like that, which is kind of neat actually. And I don't like how this UI is just kind of vibing together. I guess that's how that works. Ugh, it looks so bad though. I could shove it... How do I want to fix that? I could do a group. Maybe I'll do that. Maybe I'll throw this in a group. I'm not actually going to do this because I don't care, and my life is too short. Do I care? Okay, you know what? I am. I really, really shouldn't. I do not need to, and I was right when I said my life is too short. But it's not too bad to actually program, so I'll just do it really quickly. Okay, so we need an editing logic function. Yeah, so here's theirs. Dum-de-dum-de-dum, always copy paste. Okay, not all of that, please. Lord have mercy. Okay, I'll just copy paste the main stuff. It will be robot bearing hat edit logic is kind of the standard naming convention. And I'll scroll all the way down to the bottom. Hum-de-dum-de-dum. And I'll slap it, I'll put this down here. Robot bearing hat edit logic, right? And so then of these parameters, right? So these three are optional. If you don't include them, they just won't be passed, right? And then I don't care about hidden bodies or specified parameters. This is useful for telling what's hidden. So like editing logic, when you click a new feature, it extrudes it. And so you can, it uses hidden bodies to determine whether one visible entity is adjacent, to determine whether to set your merge scope automatically. We're not doing that, so we don't care. And then specified parameters, that tells you what parameters the user has set. So editing logic, if you change this opposite direction, then it will no longer set it for you because they assume you change it because you know what you're doing. And so they're, they just don't touch it anymore, basically. Yeah, and same thing with like merge scope and whatnot. So if you add something to the merge scope and then you click something, that way it doesn't override your change because presumably whatever you did was correct. They're not going to override it with editing logic because that would be awful. And then is creating. This tells you whether or not the feature is being created for the first time, so whether they have just inserted it, which isn't actually that useful of a check. But the other thing that's really important with it is if you don't include it, then the feature will only run on the first time a feature is created. And so make sure you have it, even if you're not using it. Yeah, definitely not the most sane behavior, but that was written in a long, long, long time ago. And so that is what it is. Yeah. So then the first thing I'm going to do is I'm going to write in this check, this guard, right? And so because basically what happens is old definition, this map is undefined, or it's this empty map when the feature is first created. And so that is not fun, because a lot of times you're doing like, comparisons on values, and those comparisons will fail if old definition is empty map, because empty map, if you try getting a key out of an empty map and it doesn't exist, it crashes. Onshape crashes. It doesn't like it. So that's, yeah, so we're going to do that. And then we're going to set definition dot hole diameter equals get lookup table bearing hat table, and then our path is going to be definition dot bearing hat, right? And then we should have a hole diameter defined, right? And then we'll return definition. Oopsies, and then we need to guard this, right? So if old definition dot bearing hat does not equal definition dot bearing hat, right? Or we'll do this. If old definition equals empty, or okay, right? So this way, this will guard us. This will run when the feature is first created. So that way it's consistent. So if like it's filled in using like old logic, it's correct. And then this will run when the features change as well. So that will work. And then the last thing we need to do is we need to add that report feature warning from the whole feature. So we'll do that. Yeah. So we'll do that. And I'll do it after the bulk of my error handling. And they have special handling for that that we don't really care about. We just need to know if our table has been defiled. And the way we can do that is when we get our table values here. So I'll just get them like here now. Right, and then we'll just check if, and we don't want to use equals comparisons because these are floating values. So we'll do tolerant equals, and we'll do our definition of hole diameter, and we'll use our, compare that to our bearing hat dot hole diameter. Right, and here now we'll use definition of hole diameter. Right, because hole diameter should be the source of truth, so that way if the user changes it, it actually changes. Yeah, there we go. Ta-da! So now, right, I see immediately it's wrong, which isn't great, but I guess, because it hadn't had a chance to run yet, so that makes sense. Yeah, so we see if I change this, it automatically changes to match, which is good, right? And then if I override it, 0.5 or whatever, then it does that, and the hole also changes. So yeah, ta-da, that works. We're very happy with that. And then I'm going to throw, I don't need this anymore. Right, hole diameter bounds, that's fine. And I'm going to throw this in a group. Parameter group, angle, I guess, and we won't have it classed by default, and we'll just slap that in there. Something like that, maybe. Kind of hate that. Let me see. Selections, general, material, relief. Selections, general. Ugh. And there's frame. Frame has groups, but it's very limited. I mean, revolve is like this, and you have your angle down here. thread. Yeah, they have a lot of add stuff. I mean, there it's up top, right? Like it's immediately before, like even the depth. And then whole feature, of course, there. I don't know. I feel like I want this up here. Like, I feel like I want this like this, right? Because those are like, this is the most common anyway, right? So if we're starting from like most common to least common, right? Like you're always going to select a bearing hat. You're always going to change this probably. And then, yeah, I think that's reasonable. Oh, one more thing I need on here, somewhat important, this needs UI hint. That needs reproduce value. Yeah. Okay. Ta-da! Cool. All right, I'm happy with that. Yeah, I think that's useful. I don't like this being named angle. Maybe I'll name it rotate? Off of like make connector? Realign, move? I might name it rotate. Is that good? Zero? I think that's reasonable. Rotate. Rotate's such a bad name. Ugh. Are there any groups in the Onshape? How do you tell what a group is? Group name. Show derivation, edit control points. I could do like edit rotation. There's a lot of edit here. Direction, partial, end conditions, trim control, inputs, general material relief, parent parameter name, access to measurements, position. Oh, these are like collapsed. Like these are like driven groups as well. I could just not have a group, I guess. I mean, this feature is small enough that I don't think I really need it. Let's see here. Okay, yeah, I'm fine with this. I'm fine with just like that, I think is reasonable. Right, that's not too bad. Yeah, I think that's about right. Termination. Angle reference. Otherwise I'd be doing like a selection group. Let's see here. Selections, general. I could do a selections group, I guess. Maybe I'll do that. How am I doing it? How have I been doing it? Hash marks, direction, selections, selections and belt. Okay, I guess I'll do that. I'll adopt that same parameter. Selections and then hat. Okay. All right, I think I'm happy with that. Yeah. And then they're collapsed by default, so I don't really expect people to use them, but I think it just, you know, adds a logical grouping to it, which is helpful. Yeah. Alrighty. Cool. So that's, yeah, that's my robot bearing hat feature. So then the next time, right, so this isn't completely finished yet. I guess I'll add a description too while I'm at it. Credit, yeah. Where am I getting this from? Robot feature. I need to add a credit in the icon. Ooh, yeah, I just have some standard stuff to add my icons and whatnot. Because I am lazy, right? So I'll just grab that. I need the icon. Because I'm too lazy to make a custom, or oh, I don't really do icons. Because I'm lazy. So I'll just do this. And I'll throw a description on here as well. Oops. Okay, cool. Great. Okay, so I'm happy with that. I think that's good enough to release. Although I'm not actually going to release this just yet, because there is, I do need to do some code cleanup, right? So right now I've just been dumping all my stuff in line. But, you know, as you've maybe noticed when we were looking at like some of the Onshape stuff, right? Especially like, I think like transform copy, maybe not transform copy. You know, you saw like in the standard library how they have like various functions to break things up, right? And how that makes it a lot more readable. So we're probably going to do something similar as well. Although I have gotten the habit of, I like just writing it all out, you know, just kind of in line. It's a little bit messy. I, you know, have to copy paste sometimes and whatnot. But once I have it all written out, that's easy to go through and like identify the blocks and, you know, chop things up. So I'll probably have, you know, like this will be a function to do like all my error handling. And then like I'll have a function to like apply my angle reference. And then like a function to get my, you know, like my bearing hat parameters, and a function to like, you know, apply the flip in secondary, apply angle, add the manipulator, and then like create the actual bearing hat holes. You know, so you can like logically break it up like that, and then like Boolean bearing hat, you know, can capture like this logic. So something like that I'll probably do in the next episode, and also probably I do want to also look at modeling some, actually 3D modeling some bearing hats as well. So if you're not just using like a COTS one, like actually modeling, you know, like a 3D printable one. So yeah, but this is the feature so far. I'm pretty happy with it, and you know, hopefully this was helpful. Yeah.